Hi friends, today we are going to talk about a very common interview question called second largest number. Okay, so you will be presented with an array filled in with some random integer values. Let's say 9, 5, 7, 3, 8, and 1. Okay, so these are the values and you need to return second largest, which in our case is A. So there could be two approaches to it. One is sorting and returning second largest element. The second last element, and another one is comparing elements. So I have seen most of the time uh, candidates reply sorting. We can sort it out and return the second last element, which is right but not efficient. So the interviewer is looking for time complexity. They prefer an efficient solution. So sorting will require two loops, whereas comparing will require only one loop. So this one is like linear time complexity, which is preferred. Okay. So interviewer might be looking for a pseudo logic, right? Or might also want you to code. So we'll cover both of these, right, one by one. So let's just understand the logic. So, say for example, if I ask you to figure out the largest element in this array, what would you do? So you will start comparing elements with each other, right? And that way you can figure out which is the largest element. So the very same approach we will follow to reach out to the second largest element. Okay. So, in order to figure out, okay, so let's just talk about few more constraint around the problem. You can always ask the interviewer, right, will it going to have the negative numbers or not? Okay, so that way you can define your constraints. So we'll cover negative numbers as well in the coding part. For the time being, let's just, in order to understand the problem in a symptomatic manner, right? Just focus on the positive numbers and initialize our variables, right, with -1. So as we so we want to find out the second largest element, so we'll take largest and second largest, right, two elements, and let's just initialize both of them with -1. So what we'll do is now we'll start. So like we have initialized with -1, we can, straight away hit the first element, which is 9, and we can compare if 9 is greater than -1. So that stands true, right? So we'll assign 9 to largest now. Okay, let's just focus on largest for the timing. So we'll assign 9. Okay, and then we'll go to another element, next element in the array, which is 5. So we'll see if 5 is greater than 9, which is our recent largest. So that is false. Okay, so we will not assign 5 in the largest, and then we'll compare if 5 is greater than -1. Yeah, that is true. So we can put it in the second largest as 5. Then we'll go to the next element, which is 7. So is 7 greater than 9, which is still our largest element. So that again stands false. So we'll see if 7 is greater than 5, which is our second largest element at the moment. So this statement is true. So we'll now replace 5 with 7. We'll go to the next element, which is 3. So we'll see if 3 is greater than our largest element, which is 9, right? This again is false, so we'll not touch the largest element. We'll see if 3 is greater than 7, which is our second largest element here. So this is again false, so we'll not touch second largest as well, and so on. So we'll go to 8. 8 is again smaller than 9, so no replacement. But 8 is greater than 7, so this is true. So we'll replace the second largest element with 8 now. And then we'll go to 1. So 1 will not satisfy any of the statement, right? So we have our largest element now, which is 9, okay? And we have our second largest element as 8. Okay, so the idea behind is we'll instead of having one variable, we'll hold two of them, and we'll keep on comparing and swapping depending upon if the conditions are satisfied or not. I hope this is clear. So so we are just iterating, right, in a single loop, and we have reached our solution. So this is better than the first approach we talked of, which is sorting. And so if you present this solution to the interviewer, I think he or she will understand that you can, you know, think of another solution, think of another approaches, right? And which is efficient. So we'll look at the coding part of it now. All right, friends. Now we will code the problem which we have discussed. Let's just create a new class called second largest and get the public static void main, and we'll create a method which will return integer because we need to return the largest element, second largest element, and let's just call it get second largest element. We'll pass an integer array. Okay, let's just call it numbers and return 0 for the time being. Okay, so we'll take the same array 957381. Okay, let's just take 9 comma 5 comma 7 comma 3 comma 8 comma 1. Okay, so we'll try to take the same. Okay, so we talked of two elements called largest element, and we will consider a case wherein we can have negative values as well. So we will initialize it with integer dot min value, which is the minimum possible value an integer array can have. And let's just do second largest element, and it is going to be bigger than the previous one, so let's just initialize with min value plus 1. Okay, so let's just keep it simple and try to figure out largest element first. Okay, so let's just write a simple loop. Okay, numbers dot length I plus plus. So we will try to get the largest element first. So let's just write if numbers of I is greater than the largest element, let's just simply assign it the largest element itself. Okay, and return the largest element. Let's just try to run this simple code first. Okay, so okay, let me just create an object of this class. Second largest equals new second largest. Then call this method second largest dot get second largest new integer array. Let's just take the same values. Okay, so we can just execute this and see if it is okay. So as you can see, it is returning 9, which is the largest element. So now as we want the second largest element, what we'll do uh, every time we come across the largest element, we'll fill it with the largest and we'll see if second largest is there or not, right? So initially both are, you know, the smallest numbers. So what we can do is we can also assign second largest with uh, the largest number. Okay, let's just do that. So so let's just assign it with the largest so that both of them are pointing to the largest element now, and if at all we will encounter any other, bigger number, we'll reassign it. So what is the output now? Sorry, let's just display both of these number here. Okay, so, let's print the largest. Okay, so this is the largest, and let's just have second largest here. So I am not writing the solution straight away because I wanted to think as if you are, so it's very good to be vocal in front of the interviewer. So it's always good to present your approach while you are coding, right? So yeah, let's just print the passed in array as well. Okay, array and do arrays dot to string. Yes. Okay, let's just see where we have reached so far. So as we can see, we have passed in the array 957, okay, whatever. And the largest element is this, and the second largest element is this. Okay, so every time we hit a largest element, we'll assign it to the second largest and so on. Okay, so as you can see, with the solution, we have largest element as 9. Okay, whereas our second largest element is this one. Okay, the reason for this is because we are assigning largest prior to, actually, so every time we are just doing a simple swap here, right? Before assigning the largest element with the newly found out largest element, we are, reassigning the largest to the second largest element. So does that solve our problem? No, because we are looking for second largest element, which is 8, but we are getting something else in our result. So that means we are not following all the constraint as of now. So we also want, so if it is not so if the number is not greater than largest, but it could be possible that that given number is greater than the second largest number, so we need to do that check here. Okay, so what we'll do is we'll do second largest, or maybe let's just say numbers of pi. Is it greater than the second largest number? Okay, if so, we will try and assign second largest as numbers of pi. Okay, so is it going to solve our problem? What do you think? Let's just try and run it. Okay, so we are getting largest as 9 and second largest as 8. So it looks like we have found our solution. But mind you, we should consider some more scenarios, right? So this is one possible scenario which we have taken. There can be another scenario, okay, which is like, let's just put a sorted array here, 1, 2, 3, 4, 5, and 6. Let's just run it now. What happens now? Okay, first we'll return second largest. Okay, let's just run it and see. So in the second array which we have used 1, 2, 3, 4, 5, 6, the largest is 6 and the second largest is 5. Okay, so this is working for this one as well. Okay, and let's just do opposite now. So let's just opposite of this. Okay, 6, 5, 4, 3, 2, 1, and let's just run it. Okay, so this is working for this case as well. 6, 5, 4, 3, 2, 1, largest and second largest. Oh, that's really nice. Looks like we have approached our solution. Okay, let's just put another test case to it. Maybe we can have another 6 here. What happens now if we have a duplicate value? Okay, so we have a problem here. So as soon as there are duplicate elements in the array, so the second largest number started to fail. The reason is we have already assigned the largest number 6 here, but we are doing when we are encountering the second 6, right? When we encounter this second 6, it is not satisfying this condition, but yeah, it is satisfying this condition and it is assigning to the second largest now. So this is our failing test case. So what we can do is we can introduce another condition. Okay, if largest is not equal to the number of I. Okay, so this should resolve our issue. Yeah. Okay, so even after having duplicate numbers, we are still able to reach to our solution, largest and second largest. Okay, let's just take another example. Say, for example, we have a negative number, maybe minus 1. Oh, sorry, minus 1, then take 0, and then pick 1. What happens now? Okay, so it works. Okay, so I think we have reached to a solution wherein things are working fine. I would suggest you to go through the solution, and if you figure out any other constraint which is violating our solution, please let me know in the comments and subscribe to my channel for more such coming videos. Thank you.